going to present to you a problem, a situation that we might run into. First, I'm going to close something on my computer that's making it really loud. Okay, so here is the problem. Let's say I've got a class. You all remember class? You don't remember class? Okay, you do or you do not? Okay, cool. So let's say I have a class. What's something specific that a class can do that we haven't seen a struct or an enum do? Cool. Classes can inherit. And we can think of inheritance as ancestor gives us a predecessor, I want to get this right, predecessor, or Levi, do you think so? Okay, great, thank you. And then we've got an ancestor, just like way up the chain. The predecessor is like maybe a parent that inherits from the ancestor, and then there's little old me. So that's an example of inheritance. It's a straight line. So one class inherits from another class, which inherits from another class. Sounds great. But there might be situations where maybe we want to inherit from multiple classes. Let's say I've got a class called food. Class called food. And then I've got a class called seed. Cool. Let's say that food, here's what food does. Food has some calories. Turn in. And then what's the error I'm getting here with food? What do I still need to do? Cool. How do I set an initializer? Init. Cool. So there's a special function called init. And let's just say calories are int. And let's say that it says self.calories are equal to calories. Awesome. Sounds good to me. Let's also say I've got a seed. So seeds are seeds of a specific plant. So let's say the plant name is a string. And let's initialize this one with a plant name, which is also a string. Wow, 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 wow. Okay. Now, let's just say self.plantName is equal to plant name. Cool. So you've got two classes. One's a food, one's a seed. Okay, great. You saved. Good for you. One's a plant, one's a seed. Let's say I have a sunflower seed. Has anyone ever eaten a sunflower seed before? Has anyone ever planted a sunflower seed before? Nice. Wait, so you've done two things with the sunflower seed? That's crazy. I can do two things with a sunflower seed. Olympia also makes butter. What? I know, I'm saying she makes it. Okay, so let's say I have a class called yeah, let's not get into semantics there. I want this sunflower seed to have both the qualities of a seed and a food. Here's a problem. Well, let's talk about that in a second. But let's see what's going on here. Swift does not support multiple inheritance. So you can't say this inherits from one thing and another. it's a direct line of inheritance. You need to know an ancestor leads to something else, which leads to something else. So we can't have multiple inheritance here. Oh my God, can you just let me get to the lesson? Yes, so we're going to talk about how we handle this situation. Levi suggested that maybe we make seed inherit from food. So we could set that up, but maybe it's not going to work in the way that we want it to, because you don't need all of the seeds out there. Like, aren't some seeds like poisonous, so they're not considered food? Let's just say, for the sake of argument, that some seeds aren't food. Fish are friends of food. So seed cannot inherit from food, and so we can't create a nice, smooth inheritance chain, food to seed to a subclass of seed. Example, sunflower seed. So just because of how we're going to define those classes, it wouldn't work the way we want it to have food as a superclass for seed, and then have seed as a superclass for something else. But I do want my sunflower seed to have those qualities. I want it to be both a food and I want it to be a seed as well. One way I could do that is I could say it would inherit from seed, and then built into inheritance is that its initializer will initialize a plant name, and then I could just say sunflower seed is going to have another property called calories, which is an int, and then I'll create an initializer where I need to get an argument called calories, which is an int, and plant name, which is a string, and then I'll initialize self.calories is calories, and then I'll call super dot init, plant name is plant name. Great, we've seen that before. But I want to separate out the responsibilities. Go away, override. I want to separate out the responsibilities in my code at this level as well. I don't want sunflower seed to have to keep track of the fact that it has calories, because I know that plenty of other things have calories. Food has calories. So now I've just got this property with no context. I could declare this property, but it has no context. I don't know that calories relate to being a food-like thing. I don't know that calories are a property of food. So there's just this thing called calories that has no meaning to me if I'm using a sunflower seed. So today's lesson is in protocols. Ready? Protocols are a way that we can handle this situation. Instead of having a chain of inheritance, we can, using the protocol pattern, so another pattern we're learning. 2 days ago was MVC, which is how we set up the files of an app. Protocol pattern is how we mix in behaviors and properties to various parts of our code. So instead of saying that sunflower seed is going to inherit from seed and inherit from food, we could say that sunflower seed uses or has adopted the protocols seed and food. So let's make that happen in a different way. I'm going to comment all of this out and we'll start again. So let's try it again. with protocols. Great. So I've got a food, got a seed, I've got a sunflower seed. Nice. Here is the format for a protocol. I use the keyword protocol, keyword. Then I have the name of protocol, which is a name. Then I have an open brace and a curly brace. I'm sorry, an open and closed curly brace. And then in here, I just have some properties. Some int is an int. Then I have some, you ready? I have some string, which is a string. Then I can have some, I don't know, functions, which is some function. I can also set up a mutating function if I know I'm going to use it in a struct. Mutating function, some mutation. Great. This is the format for a protocol. Looks kind of similar to declaring a class. Looks kind of similar to declaring a struct. Maybe an enum in a similar-ish kind of way. Not really, though. The difference is that your classes, your structs, and your enums adopt protocols. You don't create an instance of a protocol. Instead, you have your other code use the behavior and the properties of a protocol. And the way that your other properties use it is, it looks exactly like inheritance. So if I've got a class, some class that adopts, so let's make sure that word's in here. This class adopts the protocol. In the declaration, I will say it's adopting this protocol. The difference, there are a couple differences here. Whereas before, you could only say your class could inherit from one class, you can adopt multiple protocols. You can adopt a bunch of them. And this is where maybe something that we saw in that style guide about extensions might come in. Let's not worry about that right now. Just to make sure it's clear, a struct can also adopt protocols. Cool. And an enum can adopt protocols. I'm going to say these adopt the protocol. Awesome. So can someone spit back to me why we might use a protocol instead of inheritance? Sunny. Awesome. Sounds good to me. I'm gonna go over here and just do one of these so that I can do some more in this space. So that's a great point. We'll use protocols when we want to adopt some behavior and adopt some properties of multiple things in our new type, in our class, our structure, our enum. Allison. It, no, so adopt just means, you can think of adopt as inherit, but without the actual chain. So adopt just means I'm getting all the stuff from there. Correct. So you're declaring a class or a struct just like you normally might, and you're declaring a protocol somewhere else. So this protocol is just on its own. And just like we've seen with like a function or whatever, its definition is whatever is inside the block, inside of the keyword protocol. Yeah? All right, here's a key difference. I'm going to get rid of the mutating function for right now because it doesn't really help for our case. But whereas with inheritance, we could just depend on a superclass to give us its behaviors and its properties. We have to explicitly implement all of the protocol methods and properties that are being adopted from the protocol. So this protocol has some var, some int as a variable, it has some string as a variable, and it's got this instance method called some function. So, great, sounds nice. What I'll need to tell it, and this is so fun, I'm so excited for you. I'll need to tell my class that it has to implement a var of its own called var sum int, which is an int. And just like with any other class or struct, I could give it a value right now. I could also not give it a value and initialize it with that value. But I have to redeclare that property from the protocol. It has to be the same type and the same name. Otherwise, I am not adopting the protocol properly. It's not going to work. So I must have some int there. When I declare it, it can be set up in a different way than the protocol. So the protocol didn't give me a value for it. That's great. It doesn't necessarily ever give you a value for it. But I could, in my class definition, say, I've got this protocol that I'm adopting, and this int, whenever I've got an instance of this class, is 23. Yes?
Instead of having two super classes that we can't use. So this is, instead of having two super classes, we make the protocol and pull out certain properties or behaviors, but not all of them. Like I can designate some int, but I would need to take some string in system class.
Yes. So this example is like abstract and stupid, but think of protocols like as really needing to conform to the principle of separation of responsibilities. So if we go look at our example of food and seed, those do very specific and precise things, like they just have a calorie, they have a food. You want your protocols to be super slim. I'm not sure if that actually just answered your question, sorry.
First question was, in this situation, I wouldn't need, well, I guess if we go back to the
Yep.
seed example, if we were to create a protocol, we then wouldn't need superclass seed and superclass food.
Correct. So we might have protocols, and this is what you're all going to get to do in just a second. We might have protocols for seeds, and we might have protocols for foods. And you could say that a sunflower seed conforms to those protocols or adopts the methods and properties of those protocols.
And it would adopt all of the methods and properties, even if some don't apply to it?
It must. So to conform to it, like, think of the word conform not in like code, but in like English, like it's got to do everything that it says to do. So to adopt a protocol, you have to conform to everything in the definition of the protocol. So if we make a protocol out of seed, that might be totally fine, because the sunflower seed adopts the protocol seed, which just has a property called plant name. So sunflower seed might be initialized every time. It might initialize that property plant name as sunflower every time. And it could be said to conform to that protocol just by having a value for that.
What would be the benefit of using classes?
Good question. Because we tend to use structs, you'll tend to want to use protocols, but you'll see that a lot of the UI kit is set up as classes. So we do need to know what inheritance is, but I would say, just like we said way back when, default to structs over classes unless you need to use a class, default to protocols over inheritance. Yes?
And does a protocol is that also its own type then, or does it just attach to the class that adopts the protocol?
I would say think of it as a set of instructions. Rod. Okay. All right, T2IL. So our class has to conform to the protocol by explicitly creating properties for each property in the protocol and by creating some function which does some stuff. That's cool. We'll get into how you would use these functions like maybe a little later, but for now, we know that a class has to initialize all the values of its properties, right? So maybe we might say some class by default has the value 3 for that some int, and then in our initializer, we set the value of some string equal to a string. And we say self dot some string equal to some string. There is no superclass to inherit from, so there is no super.init here. Protocol conformance just means you literally have to set up the properties and the functions in the protocol. There's no super, there's no like protocol dot, there's no keyword for that. It must conform by having all the stuff in the protocol. So you have to be explicit about your protocol conformance. Phoenix.
If you just make a subclass out of that, out of some creative protocol, would it have to become a protocol or is it a subclass?
Can you give me an example? I
Like,
got mixed up.
Like with the subclass, you change the int to equal 3. If you made a subclass like that, would it not be equal to 3, would it not take from the protocols? Where it gets.
Oh. Yeah, your subclass would also conform to the protocol. Because its superclass conforms to the protocol. Great question. All right, do you want to make a protocol? Like one that works? And like does stuff? Great. Let's see. I'm going to make a really, really tough one. I'm going to steal it right from the lecture. Are you ready? Okay. Let's make a protocol. You want your protocol names to be descriptive of what information they are providing. So I'm going to make one called fully named. And this protocol demands that anything that conforms to it has a property called full name that's a string. What's an error you see about this protocol? So it's highlighting that, excuse me, it's saying property in protocol must have explicit get or get set specifiers. Allison, what's going on? Thank you, capital. Thanks. Alex, what's this error? Okay, what were those things? What were those things called? Cool. There's a more formal name. I know that's how I keep referring to him, so you're definitely not wrong. Computed properties. So here's a fun thing about the properties in a protocol. They're computed because properties are computed because, check this out, because the protocol itself doesn't store values. Instead, it says how you can go and get those values. All you have to say in the protocol definition is whether it has a get or a get and a set. So all you have to say is what type of computed value this is. In protocol, you only have to say what type of computed values the property will have. Is it read only? What did read only mean? Can't be edited. So which of these computed keywords would we have? Just get. And then, I'm not sure if this is the exact term, but read-write is how we refer to being able to read information and then write information to something. That would be when you have both get and set. You'll probably see read-write more broadly in a ton of different coding contexts, not just in Swift. So read-only and read-write I think are important for you to know. And getters and setters you can define here. Great. So we've got a protocol. That's cool. We've defined a protocol. This protocol's job is to make sure that any type that conforms to it is fully named. It does that by having a property in it called full name. And it tells you how you can use that property. You can get the value of it, and you can set the value of it. So the name of the protocol, name, tells us what its job is, loosely. We'll see like a better way to write these in plain English later. The name tells us what its job is, the properties are computed, and that's all we need right now. I'm going to make a struct called person that adopts fully named. That's cool. In order to conform to the protocol fully named, which I'm not doing right now and I'm getting an error, what must I do? So what did we say? To conform to the protocol, what do I need? Cool. So I will need to implement all properties and methods of that protocol. What? Great. So Adam, what should I do? Cool. Let's see if this runs. Forget how to run things. There we go. Run. All right, looks like there are no errors. Now let's make a person. Let Allison. Hold on, I'm making you. Can you hold on for just a second? So, Allison. Great. Let's run it. Let's see if it works. Say that again. You're right. Yeah, so if we wanted this to work better, maybe there would be two properties, a first and a last name. Maybe an optional middle name. Ooh, I know. All right, let's run it. Come on. My computer's not in love with all the things going on. Okay, whatever. It works. Because this full name is a property that makes our struct conform to the fully named protocol. Let me just go back again to computed properties. If I have the full name implemented here, but it's a read-only computed property in the protocol, if this ever runs, I might run into an issue trying to set the value because it's read-only. Sorry. Allison, what you got? Yes, sorry, yeah. Correct. Yep. Yeah. So, yeah.
That how we have the same protocol, just the same struct, given it the same command, but having to separate functions, given different functions. So it has that same function instance of the struct, but in different screens that are different.
Can you give me an example?
Alright, so if we have
Okay. Levi?
This is super cool, but if I can just create a struct with property full name, with a protocol.
Let's say, in an ideal world, all dogs had full names. And then, let's say, in an ideal world, all cats had a full name. So these can all adopt the same protocol, and that protocol is very descriptive about what it's giving to, what it's providing to each struct that conforms to it. So this is like a beautiful way of organizing your code. And it's a beautiful way of implementing new types because, as we'll see, maybe you've seen it before with, for example, dictionaries and sets. They conform to a protocol called hashable. And that was the process of hashing out unique values that we talked about and threw away. Like, you use protocols to provide the same behavior and properties to a multitude of things. You might not create a protocol just for one thing. So you might not create a protocol for, a property called bark sound. That might just be something inherent to dog. But if you want your dogs to be fully named, var full name, that's a string. So it both has its own properties and conforms to the protocol fully named. So it's for replicable code. It's for using this multiple times in your code. That's a great idea. I think it has to do with the recording, but let's quit it. Thank you for the good idea. Let's open it back up. Let's bring you back over here. It's alive. Okay. I'm very sorry, we're just going to run through to 12:45. Unless Leon has the P again. Okay. So what I'd like you to do, you've seen a tiny bit about protocols. I'd like you to implement a protocol called food-like. So meaning I'm something that is food-like. A protocol called seedy. So I'm something that is like a seed. And then a struct called sunflower seed. This is ambiguous because it might also mean scary / unsavory. But for now, just treat seedy as meaning like a seed. Think of your protocols as always saying, this protocol is for things that are like whatever you're describing. This protocol is for something that is like food, something that is like seed, something that is like a bird. It wants to fly away. So work with the person next to you. Let's give it just implement the stuff we had before and make it work, honestly. You don't have to go nuts. So let's give it 8 minutes. I'm like a seed. Yeah, that's what we did with dog. So dog has its own stuff, and it also conforms to the protocol. Yeah. So this is what you're doing.
Exactly, yeah.
Okay, let's bring it back. Let's bring it back. Let's bring it back. Yeah, I love this. Thank you all for. Okay, so can someone tell me about their food-like protocol? You don't have to come up. I won't scare you, I promise. So let's make a protocol called food-like. Rod.
All right, let's do var consistency.
Var consistency. Okay.
We're gonna make it, yeah, later.
Okay. Got it.
I guess we can also put calories.
Well, let's figure out.
Oh,
It's
wait, no.
it's yelling at me.
Yes. Let's put curly brace get and set.
Oh. Get and set. Okay.
Yeah. And then calories. Yeah.
Var calories. Say an int. Nice. Okay. What's get and set? Okay. Cool. Is that your food like? Okay,
That's all
cool.
that matters.
That's all that matters for Rod. All right, does someone want to give me your CD protocol? Yeah, what's up? What's the issue?
Well, alright, moving back a little bit, so I have not poisoned in my protocol for 2 nights. I
Yeah.
had not poisoned as usual. I had scientific name string, I'm sorry, and wool was set to get.
Just a get.
I had scientific name was set to the string, and I originally had it get set, but then I was trying to play around with it.
Okay.
Um,
Would you mind if we just break not poisonous for now?
sure.
Okay. So let's see how we break this after we define the next protocol and start making a struct. Do you want to give me your CD? Okay.
Well, I got var can grow plant.
Var can grow plant. That's a really good one. Can grow plant. Is that a bool? And what are the properties of that variable? Get and set? Okay, cool. Does anyone else want to throw some more properties at our CD? Does anyone have smaller words? Shape. Var shape. Cool. It's going to be a string. That's just going to be get. All right. So seed, just because it's like a physical object, it's probably going to have a shape. You know? Right? Like just at a low level, you know, not reading the side of the container for nutritional value. Okay, so let's make our struct. Struct. Who's it going to be? Nima, can you help me with just the first line of how I'm going to declare this struct? So I've got a struct. Awesome. Colon. CD. Awesome. All right. Let's see some errors. Are you ready for a super cool part? Did everyone see this? Your Xcode is going to be like, oh, you're trying to use a protocol, but you're not doing it right. Let me fix that for you. And it's just going to fill in all the stuff. So I'm going to keep these grouped just by the protocols that they conform to. That's cool. That looks fine now. Okay, Tia, let's break it.
Okay.
So sunflower seed, let's talk about its poisonousness.
Yeah.
So false?
That true.
Not, yeah, sorry. Can I just make it, my brain's not working, can I just make it poisonous and call it false? Okay. Poisonous, false. Cool. What about now? Nice. Okay. So I'm not seeing any errors, but I think I led you astray, and that's what's going on here. Are you ready? No, it was not intentional. I was just wrong. I'm okay with being wrong.
Let's change it from a bar to a left.
Okay. So let's see what happens here. It's like a very annoying technical thing. I'm not seeing any issues. It's ready to continue. Let's declare a sunflower seed and see if I did it wrong. Let's let our sunflower SFLS equal sunflower seed. Now I gotta initialize all these things. What's the consistency of a sunflower seed? Crunchy, awesome.
6 calories.
Oh, 6 duh. I should have known that. Can a sunflower grow a plant, Crystal? Cool. Sounds good to me. What shape? Wavy? Teardrop? Wavy teardrop. I'm so interested to know what wavy means. Okay, so let's run this. It seems like it's okay with it, Tia. Let's print out. What was it? What did I do wrong?
In terms of trying to break it.
Yeah.
So the way that I program is that I change my other variable to get set to a let.
This guy?
No. Like consistency of calories, like as in
Okay.
I did the struct, I changed it to a let and declared it. And
Yeah.
that it didn't conform to the other protocol.
Okay.
I fixed it, it just added it, and then it said there's, basically
Okay. Is it, let's see if this is the case. There we go. So I had this poisonous as just the getter. So we set a default value. let is by default just a getter, right? Once it's been defined, once there's a value, it's a constant, so it's read-only once you've given it a value. So this protocol can be defined as a var, and then you could be using a different keyword for the property here, but for the protocol to conform, the get set setup must work for the way that you're defining it. So it literally just doesn't like that you wanted to also be able to set poisonous because it's a constant. So it did that check for you, like it did the logic for you. And that was my fault. It's okay. Cool. Do you like protocols? I think they're pretty cool. And they're like a really nice way to just mix in stuff. We call this the delegation pattern. So let's look up the delegation pattern. Ready? Okay. Does anyone have a favorite blog for Swift? I like Anon Ninja. I've never heard of this person, but let's see. What is delegate protocol in Swift? Optional and required protocol. What is the protocol? A protocol defines a blueprint of methods. I wish I had used that word. It's such a good word. A protocol is a blueprint of methods, properties, and other requirements that suit a particular task or piece of functionality. That's what we've been doing. We've been creating a blueprint, or maybe another good word that I didn't use is template. It provides a template for how you might do a particular task or create a particular piece of functionality. So, in our example, functionality is to be able to make something that's food-like and to be able to make something that's seedy. Nice. We did that. Protocol can then be adopted by a class structure or enumeration. We did that. It has to provide an actual implementation of those requirements. Super important. But Xcode does you the favor of telling you when your class or your struct or your enum does not conform. That's really nice. So the protocol, when it's adopted, must be implemented in full by whatever adopts it in order to conform. That's the word. So any type that satisfies the requirements of the protocol is said to conform to that protocol. Great. That's nice. In addition to specifying requirements that conforming types must implement, you can extend a protocol to implement blah, blah, blah. Okay, whatever. A protocol you have seen many times in Swift is UI table view delegate and UI table view data source. You have not seen this yet, so this is a bad article. Let's get out of it. Yeah. That's fine. That's what the internet is for. Okay, let's look at this. The delegate pattern has long been very prominent on Apple's platforms. Delegation is used for everything from handling table view events. Yeah, okay, we don't know that stuff either, but let's see if they'll tell us more specific stuff. The core purpose of the delegate pattern is to allow an object to communicate back to its owner in a decoupled way. Huh, what does that mean? By not requiring an object to know the concrete type of its owner, we can write code that is much easier to reuse and maintain. These two sentences are so damn good that I'm just going to steal them. The core purpose of the delegate pattern is to allow an object to communicate back to its owner in a decoupled way. So, I'll put this playground up real soon. Okay, I'll slack it. Jeez. 6.1 iOS. Did you know that you can insert parentheticals by using the greater than sign? Check Slack. Anyway, this is such a good description of the pattern we're using here. So the protocol pattern, you can say more broadly in code that the protocol pattern that we're using here is a delegate pattern. So you are delegating, you are not requiring an object to know the concrete type of its owner. Instead, you are allowing it to communicate to its owner in a decoupled way. Think of the protocol right now as the owner and the object as whatever struct or class or enum you are defining. You're going to use a million of these. It's going to be really helpful to know about them. Hallelujah. Let's read some more. Just like the observer pattern, which we haven't done yet, the delegate pattern can be implemented in many ways. When to delegate. When to delegate. This is a really good article. Swift by Sundell. The main benefit of delegating certain decisions and behaviors to a type's owner is that it becomes much easier to support multiple use cases without having to create massive types that themselves need to account for all those use cases. So like if you had dogs, cats, humans, elephants, birds, and they all need names and they need a genus, and oh my God, you could just make a protocol called the genusable, and then they could all conform to that protocol. And then you just change that protocol in order to talk about things that have a genus. Awesome. This is a really good article. Oh, and now they're just copying and pasting from the other one. Take UI table view, UI collection view. Both are extremely versatile in terms of that. Delegation is usually a good choice when a type needs to be usable in many different contexts. Boom, stealing that. I will paste this link in our Slack. Boom. It's so good when I don't have to do the thinking. Boom. Thank you for the pomegranate. I don't think I'm ever going to live that down. Okay, protocol. It's the most common way of delegation that's found in Apple's own APIs. API is a really important word. We'll talk about it next time you do DSA maybe. Is by using delegate protocols. We just learned that. Here's a protocol. Nice. Something to do with any object. I don't know. But, oh, I don't like that. Here's a class that has a delegate that is this delegate. Let's not worry about that right now. But we defined a protocol, and let's just say for now, this class is using the protocol in a specific way. So the delegation pattern, well, it's a little different than what we saw, right? We might do file importer : file importer delegate. But we're going to get into what delegate and data source mean, I think next week. I don't know. But there are a ton of protocols that get used specifically in UI and when processing files that we are importing. So that's cool. All right, I'm going to stop reading this, but there's plenty of other stuff you can read. This is called the delegate pattern. So using protocols is one way that we use the delegate pattern in Swift. If you see the delegate pattern in, let's say, 5 minutes when you go into Canvas and you open up the midday check-in, it's referring to this kind of pattern. So I would encourage you all to think about the exact words that I say right now. The protocol pattern is an example of a delegate pattern. Great. Cool. All right. And it's also a really good thing to be able to explain in interviews. This is a very high-level coding thing. This isn't just implementing seeds. This isn't just implementing food. This is saying how I manage my code, how I make my code much more repeatable and easy to use. It's a really high-level concept that we're learning right now, and it's going to be something that you'll use for the rest of your professional life. So that's really cool. We can make it conform to a protocol, or maybe we could look into what the protocols it already conforms to are. So there are a lot of built-in protocols that you can see. Yes?
Word. So delegate, so the delegate pattern is the type, whereas the way information is flows by using protocol. Is that?
Core purpose of the delegate pattern, blah, 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 blah. A delegate pattern is a way by which we pass behavior and properties and other functionality. And in Swift, the protocol pattern is a specific way in which we implement the delegate pattern.
The delegate pattern is a concept for all languages, and in Swift that is protocol.
Yes, other languages also use protocols, but the superset is delegate pattern. Okay, wait. I feel like we should do one more thing. Oh, we should do one more thing.
Are there two big
Are there two?
examples?
Oh my god. That's so upsetting. Oh no. Oh no. Okay, I want to show you one thing. The only other thing to see for right now, and we'll come back to it, I think we should come back after lunch and do some more protocol stuff. I don't want you to just go off into the wild. Let's say, what can these protocols do? Food like. Calories is a var, we can get and set it. Let's say there's a mutated function called munch. We just say, if we want to use a function in our protocol's definition, we just say what happens when we say what arguments we might need and what return types we might need. We do not define the function. We're just saying, here is the pattern that you will need for when it's a blueprint, it's a template. When you conform to food like, you will also have a mutating function called munch. So now my sunflower seed doesn't conform to it. Let's fix that. Great. I'm gonna put this down here, and I'm gonna have a mutating function called munch. Nice, thank you. And it's going to say, it's going to return self. It's going to return calories. Calories is an int. So I've got my sunflower seed. It's got 6 calories. I've said let's let 1 mouthful equal SFLS dot munch, and then let's print I just chewed 1 mouthful. Come on. Come here. Come here. Come on. I just chewed 1 mouthful, 6 calories of that SFLS dot consistency sunflower seed. Cannot use mutating member on immutable value. Sunflower seed is a let constant. Wow, fix that for me, please. So I can't mutate my struct. We've seen this plenty of times before. I can't use a mutating function. I actually don't think this is mutating, so let's just change that. I'm just returning a number. I could change my struct to be a var, but maybe I'll just reconsider the definition. It's probably a better idea for me to think through what munch is. So if I'm just returning the calories, let's print this out. blah, blah, blah. I printed that. Yeah, okay. Let's do it again. I just chewed one mouthful, 6 calories of that crunchy, awesome sunflower seed. So this now conforms to its protocol, even with the function here. So a food-like thing must allow you to munch. Sunflower seed is food-like, so it implements munch, just like it implemented the properties. That's all, folks. What are some questions as you take your midday check-in? Again, the super nice thing about protocols is if you're explicit in your protocol about what it must do, anything that conforms to it, the program will tell you if you have or haven't conformed to the protocol. I just cracked my knees and ankles. Yeah, it's really good. Okay, I'm going to stop recording.